everyone, welcome back to the channel. Today we are going to discuss about standard normal distribution. In the previous video, we discussed normal distribution where outcomes have different probability and the distribution of the probability resemble a bell-shaped curve and peak forms at mean. So what is standard normal distribution? It is actually a type of normal distribution only where probability distribution again looks like a bell-shaped curve. It has all the features of a normal distribution curve. The only difference between a normal and a standard normal distribution is that in standard normal distribution, value of mean is 0 and value of standard deviation is 1, whereas in normal distribution these values can vary to any number. Now following is the formula for calculating the probability of a variable in case of normal distribution. But for easier calculation, we always choose standard normal distribution instead of normal distribution. Here, probability of z-score is calculated after converting the variable y into z-score. Standard normal distribution is also termed as z-distribution and a table which gives probability of the z-score is called as z-table. Now, calculation of probability in case of standard normal distribution can be boiled down to a few steps. Step 1. Convert the values of the variable into values of standard normal or say z distribution. That is, convert the values of variable into z-score using the following formula. The next and the most crucial step is step 2. That is to find out which area of the z distribution curve do we actually want to find. Third step is to find the probabilities of the z-score in the z-table. And the last step is a need to do basis step where you add or subtract the probabilities accordingly. Let's take 3 different examples to demonstrate how these steps are executed. Example 1. Find the probability of a variable to lie below 3 where data has mean 8 and standard deviation 2. Let's go through all the steps one by one. Step 1. Convert the value of the variable into z-score. Now following this formula, we will get the z-score of 3 as minus 2.5. Step 2. Find out the area of the z-distribution curve we want to find. Now let's shade the area on the curve for value less than minus 2.5. Step 3. Find the probability of z-score, that is minus 2.5 in the z-table. In z-table, first 2 digits of the z-score are found in the rows and the third digit in the column. So how exactly do we use the z-table? So for a z-score of minus 2.5, first 2 digits of the z-score, we will look for minus 2.5 in the row. Then after getting the row of minus 2.5, we will look in all the columns of minus 2.5. Since the next digit of 2.5, that is the third digit, is 0, so we will take the first column 0.00 and the probability for that value is 0.00621. But as I described in the previous video, for continuous data, probabilities does not exist for a variable but for a range. So what is the range that is being considered for variable or z-score minus 2.5? Generally, at the top of every z-table, you will find that a note or a graph that the probabilities represent or the table values represent the area to the left of the z-score, which can also be interpreted as the area less than or below the z-score. So the probability we got represents this area of the curve, which is exactly the area that we wanted, which we located in step 2. So we can say that probability of a variable to lie below z-score minus 2.5 or say variable 3.00621. So let's go to example 2. Here we have to find the probability of variable to lie above 11. So let's go to step 1 again. Convert the value into z-score, which for 11 will be 1.5. Step 2. Find out the area of the curve, which will be this for greater than 1.5. Step 3. Find the probability in the z-table. So for row, we will take the first 2 digits, that is 1.5, and for column, we will take the third digit, that is 0.00. And the probability value will be 0.93319. But the value represent the area below 1.5. Whereas in step 2, we saw that we want an area above 1.5. So this time we will go to step 4. Now we need to add or subtract. Here, in case we want the area greater than 1.5, so we have to subtract the area below 1.5, which we got from the z table, from the total area under the curve. But what is the area under the curve? Remember, I told you in the previous video that area under the curve adds up to 1. So here also we will subtract 0.93319 from 1, and that will be our answer. That's why I told you that step 2 is crucial, because z table provides a particular area of the curve only, and that's why people often get confused if the value they got from the z table is actually the value they want. Now, another way of going through example number 2 is that the area of probabilities below minus 1.5 and above 1.5 will be same because of the symmetrical nature of the graph. So one can just calculate the probability below minus 1.5 from the z table, which will be similar to the answer we got earlier. There will be no need to go to step 4. Now, since this video is kind of going too long, I will discuss the rest of the examples in the next video. So that's it for today. Thanks for watching. If you learned something from the video, then please like, share and subscribe the channel.